Okay, well, welcome everyone to the IWRS. What month are we in? We're in August. My God. Welcome to the IWRS August webinar. We are very fortunate to be joined by Fred Keijzer from the University of Groningen, who is going to be talking about the Sphex story and how humans keep repeating themselves. I think this is going to be an update on one of Fred's papers from some time ago now that I read recently and thoroughly enjoyed. I think it's a fascinating story, and I will not keep you from Fred any longer. So, Fred, over to you. Please take it away.
I start. Okay, thanks for the invitation for this society, and I'm honored to be talking about the Sphex story because I've been working on it for quite some time, or mostly some time ago, starting in the 90s, and then 10 years later again, and I had a paper out in 2013, which, if you find the talk interesting, might be interesting too. I must warn you, I am a philosopher. I am not knowledgeable so much about insects. I do love insects. I like them as critters, but I don't know so much about it. So this talk will be a philosophy talk, but it will also be about this wonderful being, the yellow-winged Sphex, which is the heroine of today. It's a species of Sphex flavipennis, and it has made a big impact on cognitive sciences. So, from that perspective, and it is a philosophy talk after all, so why would anyone be interested in digger wasps? Because this Sphex is one of a bigger family of digger wasps. And why, you might ask? You that probably is not an issue because you're just interested in insects, and so also in digger wasps, and it's not an important question, but this digger wasp, this wasp, has become well known way far outside of entomology, and has become well known in the cognitive sciences more generally. It was when I studied the philosophy of cognitive science ages ago. It was a wasp that I knew, and it was the wasp that had a particular meaning. And this particular meaning is what I called Sphex story. And it is on this story that I want to focus. Basically, the story itself has several features. It is about this Sphex wasp. Among most readers coming across this, they have no idea what it is, but they are told that this is about a solitary female digger wasp who digs her nests somewhere in the sand to lay her eggs in. She provisions her nest with crickets, at least for Sphex. It's crickets what the brood get to eat. Other genii, I don't know how to say this, they are similar to Sphex, but from a slightly different genus, but similar in other ways, with the same behavior. They feed caterpillars, flies, or spiders. Basically, there is a hole in which the Sphex wasp brings this food, and she does that when she has first catch it, she brings it to the nest. What she then does, she opens it up, goes inside, and takes the prey and brings it in. And issue here is that if you are looking at this and interfering, she can be made to repeat herself endlessly. And the story, in the original story, it is even 40 times. So 40 times is very significant because that signals that it must come, or is presumably must come, from the same source as different versions go. And basically it shows much about insect behavior. It's highly similar to basic computational routines many computational scientists will find, and which also can stuck in an endless loop. So, way to refer to this is the cricket test, which is specifically the procedure this is about. I'll just explain it quick, because if you don't know it, you don't get the gist, only get the gist, but this is what it's about. So when the wasp arrives at the nest with her prey, she goes inside, leaves the prey outside, cricket, caterpillar, spider, whatever. But this goes mostly for crickets and caterpillars. When you displace this prey, when the wasp is inside, and put it somewhere at a short distance from the nest, when the wasp comes out, she sees there's no prey, she sees it lying a bit further on, she goes outside of the nest, grabs the prey, brings it to the entrance again, goes inside without the prey, and then does the same thing over. And when you are patient, you can do this again and again, 40 times. So this is the cricket test. If you displace prey from the entrance of the nest while the wasp is inside, you're performing the cricket test. And this idea of Sphex story, that this is something you can do with Sphexes, with Ammophila, and so on, is widespread, something that is important. And it came to fame in the cognitive sciences mainly. This is where I got to know it first. It's now a bit diminished because I've been, and other people have been, arguing against it for some time now. So we'll talk about the story itself, also about the origins of the Sphex story and its status in ethology. This is part 1, that's the main part of the talk, and then I will do part 2 and 3, which is more at a meta level. Why was this story picked up? Why did it spread? What is this about? What did it do to us humans? And at the very end, I will have a look, like an update, you might say, why do I still keep the Sphex story alive, and why do I still retell it now and again? So, Sphex story in cognitive science was first introduced there by Daniel Dennett and Douglas Hofstetter, both super famous. Daniel Dennett must be known, he died this year, class. Very influential, many great ideas. And one of these ideas was sort of the idea of the Sphex story. He first mentioned it in 1973 and then kept on going with using it in his famous book on free will in Elbow Room. He used it to a large extent using Douglas' notion of sphexishness, being not free, driven by causes, as the central claim of what insect behavior was about. The idea is that Sphex is driven by the stimuli it's encountered. If it gets out of the nest, doesn't see the prey nearby, so she does. She picks it up and repositions it in the place where it should be. This story has been widespread everywhere, and I just will show you some of the quotes of people that use this story over the years. One is Kim Sterelny. Sphex has a single invariable behavior program. Vogel, it's just like a calculator. Matthew Elton, all Sphex wasps can be caught out by the experimenter, and so on. What is important here, or what I think is really relevant, is that it is taken as a God-given fact that this is what Sphex wasps do. If they are in their hole, come out and they see the prey displaced, then they invariably do the same thing. This was common sense in the cognitive sciences for a long time. So, having seen or knowing how this happens, or how important it was in the cognitive sciences during this period, must have a source. It must come from somewhere. And the main source that most people used were Dennett and Hofstetter because they were so widely read. Dennett and Hofstadter also got their story, or they got this account from someone else. And this person was Dean Wooldridge. He was someone writing on the sort of exactly at the period when computational processes became more popular, computational processes to understanding the brain and the mind. So he had various books, including the machinery of the brain and the mechanical man. Both were used by Dennett and by Hofstadter for his account of the Sphex wasp. And when I was seeking out where this story came from, because I had independent evidence that came from someone in particular, Henri Fabre. It was unclear how Wooldridge would get it. So the reference list was not too long, and finally I found it in Wells, Huxley and Wells, Volume 2, and there it was somewhere among a lot of pages. I could find the Sphex story. It was a full story, including the 40 times repeat, as we would expect, as well as a reference to its original source, Jean-Henri Fabre. And it was really a search. So Wooldridge was really a dead end if you were a cognitive scientist and wanted to know what this was about. And in particular, because Google search, nowadays it would be very easy to find a source like this. But for a long time, it was much less self-evident, and you really must put in an effort to make this connection. So within the cognitive sciences, the Sphex story was widespread, but without the connection of its original research. This original research goes back to, already said it, Jean-Henri Fabre, living in the 19th century and a bit beyond. He was a very well-known and entomologist, someone who made insect behavior widely popular with a wide audience. He's still remembered mostly for his 10-volumed, about 9 or 10, Souvenirs Entomologique, and that he started in 1879 and that he kept up for at least 10 years or longer, with all sorts of anecdotes about insects and how he interacted with them. He was very accessible to read. It were nice pictures. He had his own quirks and his own. He wrote very lively. He even was nominated for the Nobel Prize at some time, but didn't get it in the end. He was also very much a religious man and saw in his studies a way to investigate God's work, and was very much opposed to Darwinism from that perspective. What he stressed in his work was the idea that animal instincts, and also so the wasps, were perfect, given by God, and totally the best option for behavior, so to say. They were very stable and they were static. It's the main tendency of his thinking. It's more nuanced, of course, but this is sort of good for now. This audience, this context. So it's appeared first in volume 1 of Fabre's Souvenirs Entomologique. And later I discovered that it was much easier accessible in English translation of his work from 1950. And I even discovered later again that the book that was already published in 1915 is still in print, and you can just buy and read it. It's still ongoing there. So the world from, say, Fabre and his background and the cognitive scientist was very much separate worlds that were not connected for a long time. But if you go to the Fabre's world and the people who studied insects in the late 19th century, the early 20th, then it is a story that was also picked up there. People talked about it, people were intrigued by the cricket test, and they really try to repeat it, because it is rather outrageous to think that wasps, who are very intelligent in building these nets, providing for them, providing for the brood, all sorts of things, were so rigid and so non-intelligent, so to say. So the Peckhams, George and Elizabeth Peckham, were also entomologists at that period. They studied insects, spiders, all sorts of things. And they were very much influenced by Fabre's work, which they knew intimately. And they came up with their own tests to repeat the cricket test with an American species. And what they found, that it did not repeat so much. It did repeat, but after 5, 4, and 7 repeats in 3 trials, it would sort of just skip the whole thing and grab the prey and just throw it in. Stronger or more important, actually, is that Fabre himself, even in the actual text in which he reported for the first time this 40 times repeat, also find other colonies with these Sphex wasps. It's not really a colony, it's just that they live together in specific places. So they're separate, but they're living together. But other places he couldn't do the same. He didn't have the same finding of 540 repeats, but after 2 or 3 times getting into a loop, they just sort of rid of it and just draw the cricket in. And he talked about strong and weak-minded tribes, or smarter and not so smart tribes of wasps make this so. From the very start, it was equivocal what would happen. And both cases, it was not so that it was not true, because the 40 times repeat did happen and could be repeated, at least to a large extent, on other occasions, but it was just an option among many others, and many wasps didn't do it. From here on, the story unfolds, and it's taken up by the real ethologists, who became much more, their experimentation became much more sophisticated. They did much more rigorous experiments, and they were sort of really developing the fields with the famous names of Nico Tinbergen and, well, from the Netherlands, Gerard Baerends. Nico Tinbergen is, of course, more well known. But he did research on the bee wolf. I'm not certain whether that's the proper ordinary English term, but it is a wasp species that hunts bees and does pretty much the same with it. Baerends did a lot with Ammophila. And they just knew about the cricket text, and they tried to repeat it, or did some experiments actually. So in particular, Baerends is interesting here because with his Ammophila species, he got results that are a bit similar to Fabre's 40 times. He mentions a 20-time repeat in certain cases, which is a bit less than 40, but still, but also other results. And he thought it was mostly fixed, but still it was an ongoing business. And just as an afterthought or thought about what is going on here, one way of thinking about this repeat that you can induce is just compared to tying your own shoelaces. You learn that when very young, and you do it just as you do it always. And if someone would sort of mess up your half-tied shoelace, then how do you tie your shoelace again? Easiest to start from the beginning. Just go back to the beginning, and then you do the, because that's easy. So actually, even the kind of repeat that the wasps showed were maybe not as dumb or non-intelligent as we might think. Just as a sort of interpretation way of thinking about how you might see it in another light. But most important when it comes to Tinbergen and Baerends is that they did not only do the cricket test, cricket test was a sort of minor issue or even an insignificant issue that you did for fun because you have read about it. And Nico Tinbergen was, famous or became famous for many things, but one of his important works was on the bee wolf. I didn't know I got a visual here on the name, so I did say it correct. Basically, what he was interested in is how these wolves, these wasps, find their nest again. So he put pine cones around them, around the nest, so that they would find the nest and then displace the pine cones and see where they would go. And so could prove that the pine cones were indeed the landscaping guideline that the wasp used. And this was one part of a much wider research into getting clear on how they actually found their nest and would orient themselves. Henri Fabre did a lot of work. He did so much more work, of course, but what was important in this context is that he showed that Drosophila were capable of keeping track of several nests at the same time and assessing how much new food they would have to bring on which days. So it was really, really complex. And this heat that you can get into yourself when you tie your shoelaces is sort of insignificant aside, given the behavior that they also showed. So the whole picture expanded, and something that seemed intriguing if you know nothing turns into something which is a minor hiccup in a very complex system. So from here on, the story just slowly disappeared from the research agenda. I found several people still writing on this, but they were hard to find, and they didn't say so much. And when they did this, it was a lot of, it became more complex experimental setups. And they're all, in all cases, both Walter Tushner and Jane Brockman, they were the most important ones, but also some others, a few. They all came to the conclusion that there was some fixity in the behavior, but also a lot of flexibility and variability. Brockman was the last serious investigation that I could find, actually. And from here on, the Sphex story turned into a minor detail that was not very relevant. And I talked to Evan O'Neill, well, actually by now, quite some time ago, what his knowledge was about the Sphex story. I said he never really heard of it, or he might have sort of maybe. And actually what he had heard about was sphexishness and Dennett's story. He didn't mind at all that wasps were so stereotyped in this perspective, because actually he thought that at least they would get some attention by a wider audience. So this was his take on the Sphex story. So to conclude, the Sphex story just died out in ethology, and it, because of there was so much to know, so much to see, and insects are much more complex than how the story is portrayed. So it's intriguing then, right when the story died out, Woolrich displaced it to a very different context where nobody knew anything about bigger wasps or wasps in general, any insect actually at the time. And brought it to its current fame without all this background knowledge, without the critique and the nuance. Also a place where it could thrive again without clever people saying, well, actually it is much more complex and so on. And so it became so influential, probably. But that's not all there is, because given what you do, what you know about the story, it is also a story that was picked up also initially within what became ethology, and people did react to this. So there is something about this story which is interesting, intriguing, and that helped it spread around. So this is what part 2 will be about. This is more as historical and more sort of way of analyzing what is going on. First, there are two things that I want to say. And first, I will be very brief. This is about basic similarity to basic similarity of this text loop, basic computational routines that also can get stuck in a loop, which was something that people doing their first computer programming are very familiar with. Not with WASP, but with computer programming. This is something that seemed very obvious and very basic, and I will not say more than what I just said. So what we will focus on is how it is an intriguing case of unmasking, how it can be, how it works on us, so to say. This is the following thing, I think. Story seems at least to reveal something which is very deep about insect behavior. It says that at heart it is actually mechanical. We now know that this is not the case because of all the research that's being done, but if you only focus on the story, if you put context aside, it still seems something important, something significant is going on. And what is significant here is that without the test, you see something that is looking like intelligent behavior, and then by just doing this simple procedure, it turns into something that is purely or merely mechanical, and it only seems to be intelligent. So it is a demasking and unmasking of seeming intelligence rather than turning it into something which is something else than what it looked like. This is also a case wherein something comes up before about our own thinking of about intelligence or mind. Mind is a word that is very often used in the computer science, at least, but maybe here it's better to talk about intelligent behavior versus mechanisms and mechanical behavior, which is requiring less, so to say. That's the idea that by doing this procedure, the wasp seems to shift suddenly away from one category, being intelligent, mindful, and for some people even conscious, so to say, to a very different category, to being a mechanical, mindless, and definitely a non-conscious entity. So it is something that gives you power about what you're talking about, this wasp. And this is something which has been researched in humans much more widely and also for a long period. The story touches on an intuitive tendency to differentiate between mind and intelligence, let's keep those together, and mere mechanisms. Just sort of as an example, some time ago there was a robot company. They had walking robots and they were very robust, and they looked very animal-like. Well, not animals, of course, but they looked like that. And someone gave a shove, kick you might call it, but it was actually not really kicking, it was pushing it very hard. This robot with his foot, a lot of effort in it, and the thing just went over the place, but didn't fall down. And from here on, many people reacted to it as if it was a sort of robotic cruelty against robots. Well, actually, it was a feedback system that was very complex, but it was not a mindful or intelligent being at all. It was just a walking robot. Now, you might sort of get into just a walking robot. Isn't this just what it is all about? The point is that we seem to have two mindsets when it comes to this. This is also what bears out in all sorts of research, where humans can be said to differentiate between mindful and mindless entities in a way that is innately, automatically, and spontaneously. Marr and McRae are quoted here, but Scholl and Tremlett and others, many others, are also sort of have been working on this. And this quirk of us, you might say, because It is also research which is not doing so much maybe when it comes to looking at ourselves in a more general way. But it is there in research, and it is stable. It is just very much part of our human constitution, at least it seems. Someone else, Justin Barrett, introduced, is an evolutionary psychologist working on the origins of religion, where this also has an impact, he thinks. He introduced the notion of a hyperactive agency detection device. Basically, the claim is it is important for us to be able to detect agents. If you're walking on the grass in a wide field, and all the grass doesn't matter so much, rocks doesn't matter so much, agents are ones that you should be careful with, because agents are not static. They might do something to you. If you want to eat this agent because it's also an opportunity, then you should pay attention because it might not let you approach. And if the other agent is a lion or so, then you want not that agent to approach you, so relate to that. So there's a very fundamental functional difference between agents and things, and tough, so to say. Barrett stresses that we must be hyperactive to this, because missing an attacking lion is lethal, while missing a stone that you might bump into is not so lethal at all. It might sort of your toe into a painful state, or what. So he claims that our minds are made up in ways that make us very easily detecting agents, even sometimes in cases where they're not, so like the robot I just mentioned. So you also need a good off switch to counteract this hyperactiveness. When you are sort of seeing something in the corner of your eye, and then you look and it is nothing, it's just a moving branch, then you should turn off. Otherwise, it would be too much. You would lose energy in getting rid of something that is not relevant at all. And this is also something about the experimental background of this agency effect. This difference, basic difference in our minds between just causality, bumping billiard balls, so to say, and NMSC is a more technical term that's often used. So when it comes to causality, there is this launching effect. You see the two balls. Let's think of it as billiard balls. The red one moves, the green one moves after the collision. Here they're not actually billiard balls, they're just graphs on a screen. And they can be made to do all sorts of things. The green ball can move on a tangent, it can push back, it can do anything. And that's all of this is sort of weird for us. And it is what we not expect, because we expect a more billiard ball effect. This is causality of how we see it in a way that is intuitive for us. In contrast, NMSC, we can have, this is just one still from the very well-known Hyder and Timmel movie from 1944. If you're interested, you just Google it and you will find there's no time to go into that here. It's also not necessary. You will see how moving blocks, triangles, and a circle are interpreted automatically in terms of agents that are sort of being threatened, eloping, and so on. And also is that the experiments sort of come up with more the boundary cases of this interpretation. And it seems that as soon as you get power over what seems to be an agent, it ceases to be an agent. So getting power about the triangle, who is an agent in the lower case, just is a way to sort of get rid of the effect. And it becomes just some ball that you can push and pull and things with, like the billiard balls in the top case. So this is important when it comes to the Sphex out and the cricket test itself. Because in the cricket test, at least when it works, as Fabre first presented it, moving the cricket is your road into controlling the wasp behavior. And because you control it, it is not an agent anymore. When you don't control it, it looks like an agent because it seems to be under its own will. So in a way, the Sphex story provides a sort of conceptual switching device where the Sphex can be switching from a potential agent or being seen as an agent into a mere machine, even much more like us when we sort of stress its options for behavior and its activity as a moving, the free agent, so to say. And this is why I think, or this is my sort of proposal for understanding why the Sphex story has this power over us and what it does with us and why we find it intriguing and why it really controls our thinking when we encounter it. And knowing about this might make it easier to control ourselves when we are confronted with it. So if this works, it can be shown, or at least, well, gives a possible interpretation of how the same switching device can be used in various arguments for sometimes contrasting philosophical positions. Someone been working on this. And just to stress the difference between Fabre's dualist position and Dennett's materialist position, what happens with the cricket test is, for Fabre, what made it interesting for him potentially, is that the Sphex, which seems so smart and so insightful, could be bracketed together with the machine because it was actually not smart. It could sort of be controlled in a very specific way. And when you come to Dennett, for Dennett, it was showing that same that the Sphex was machine, mechanical, but he used it to stress that the similarities between us and Sphex, looking very intelligent, capable of being an actual agent, actually were an illusion, and we could push the bracket even beyond Sphex and across ourselves so that we would fall in the same mechanistic, basically, domain as Sphex and the machine. So you can use it in reasoning, you can use it in taking in positions, and it's good, interesting, I think, to think of the Sphex story in this more philosophical, rhetorical way. Which brings us to part 3. What next? Because actually you might say, well, we could just forget about the story, and why should I? A lot has changed because the paper that was published in 2013, actually written mostly in 2009. But then rejected because people just didn't see the point so much. It took some effort to get it published. So you might also say, well, it's old story, why bother? And this is what I want to end up. And there are 2 things that I want to stress here. First is that it's important to unmask this unmasking business that the Sphex story is about. Having the story told, having the paper out, has its effect. And maybe it's not just my paper, that would be a bit presumptuous, I suppose. But what has also changed, I think, is Google and computational searches that have become so easy since 2010. It is now so much easier to find origin of the story, even if you know nothing and you just read Woolridge or Dennett and see where does this come from. And then there is much more material that lead you directly into the origin stories and also in the equivocality of very finding. At the same time, one of the reactions to my own story, to my paper, was that it was told roughly like this. Well, actually, it might be that the story is not as clear-cut as it might be, but the point itself is clear enough, and mechanistic aspects of insect behavior remain clear. So it's just sort of not used. So I think this masking issue is something that remains important to some, remains important. Also, primarily as a short-term goal. You can fight tendencies, but they will pop up, and as soon as you don't pay attention anymore, and then the story might spread again. So, given that it goes to basic intuitions and how it works, we just discussed. But also, what I think is important is that it has been shown, at least within ethology, that the story can be sort of not so much debunked, but just sort of loses its potential to influence us. So rather than saying that we must move beyond these rhetorics, it is important that we focus on ways to get out of this kind of looping behavior that we are prone to when it comes to invertebrates widely, insects, crabs, worms, so many other organisms, and that this is the long-term way to deal with this. So I will finish with saying a little bit about something that is called basal cognition by us. This is the research I've been involved in more recently, together with other people. And basically it is about intelligence, intelligent behavior, cognition, memorizing, planning, all sorts of fascinating findings that you can find by studying a much wider range of organisms. So it's not only about insects or animals, it's also about fungi, it's also about plants, slime molds, bacteria. And what you see is that as soon as you really start looking, do research, then there is a world to gain in understanding of how these organisms make their way in the world and how they are doing things that we would call intelligent if we look at it from the proper perspective. So this is work that's done by Pamela Lyon, Mike Levin, Lev Arendt, and myself, and collected here in this special issue from the Philosophical Transactions. There's another, it's 2 volumes, but for the one picture would be enough. And what is important here is not say that we are like bacteria or bacteria are like us or that slime molds, etc. Point is that they are super interesting, that there is so much to learn when it comes to intelligence, towards being mindful beings to some extent. There's more to say about them than has been sort of accepted until now. So that's it. This brings me to the end. Message of the Sphex story is that insect behavior is extremely rigid and like a simple behavioral routine. That's just not true. That's not supported by the available evidence. Much more complex, there's much more variability. The unwarranted repetition of the Sphex story suggests that humans themselves are here caught in a loop that reflects our own salient, unwell distinction between mindful beings and mere mechanisms. So it's us who are should be scrutinized in this case. The basic remedy is just study these organisms. So, okay, if you study insects, that's what you do. But there's much more than insects. There's also other life forms that walk, crawl, swim, or just grow this earth. And getting to know them better will help us sort of moving beyond the Sphex story or new versions of the Sphex story that might pop up later times. So thank you for your attention. If you found this interesting, want to read up more on this, then this is the paper from 2013, where I sort of came up with the basic idea and what was going on. Thank you.
Wonderful. Thank you so much, Fred. That was an absolutely fascinating talk.
Thanks.
Genuinely, thank you so much for joining us and go showing us your work from a decade ago in a new light. I will add for the participants, I forgot to mention in the very beginning of this, because I always forget, you can ask questions. There's a Q&A tab, so please feel free to type your questions in for Fred. We have 10, 15 minutes in which to go over some things. I do have some questions already, so Fred, if you're ready, I will dive straight into those.
Sure. Yeah, I think okay for me. I just sort of I'm here for you. So
Okay, great.
should I just sort of stop sharing, because then I might see more people, but maybe it's handy to have the screen up still.
I'd say maybe keep the screen up just in case there's slides or things you want to refer to. So our first question is about the machine metaphor. So the machine metaphor has been used time and again for animals, from Descartes' dogs to the Sphex story.
Yeah.
What do you think are the benefits and drawbacks of this metaphor in shaping our thinking and hypotheses about animals?
This is how we think. So I think we need metaphors to think us through all sorts of new stuff. And when it is all settled, and so we might sort of polish it and make it more objective, so to say, but we need metaphors to make us think. Machine metaphor is something that is so basic, so fundamental to our thinking, that it is, yeah, it moves us and makes us think about objects in a certain way. Also, say the opposite, the mind or the mindful entity is also a metaphor, which is intelligent, which you can ascribe to anything basically, and which makes it do things. So we're stuck with metaphors, but being aware that we are using metaphors helps you to think of other metaphors that might help you further along. It may sound a bit bland. Basically, what I'm going to say is that if you are working on this topic, and I've been trying to work on this topic and make some progress, is that you are in a field or are in a space where these metaphors are hugely influential. So you must deal with them. If you encounter someone, then he will think in terms of machines or maybe living souls. This is how you, and the challenge, I think, is to try to come up with things that navigate between these extreme positions. Because, yeah, sometimes we are mechanical, we do stupid things where we don't learn. And the same goes for the wasp. And sometimes we are really brilliant. We come up with something, a really fascinating solution to a daily problem, whatever. So how can we sort of elaborate this or understanding of a problem by adding different metaphors or different ways of thinking? So I was happy with the shoelaces. That's a new invention, because basically it sounds so stupid for the Sphex. If you really focus on the story, you see it and you can make it repeat, and they keep doing that. When I think about tying my shoelaces, how would I tie my shoelaces without really making it becoming very complex if you must sort of recognize a setup, where it is and what you do then? It's just so much handier to just get a new and just tie them. And so having shoelaces in my mind now, I find the Sphex less stupid. And I think it's again a metaphor, and it helps me change my mind a bit, and it might help other people change their mind a bit. And so use them to the best of your abilities and try out things. I think I should be there on this.
I mean, to build on that slightly, you know, as entomologists, I think we're often confronted with this idea, specifically and particularly of insects as machines.
Mhm.
And something I thought I wanted to get your opinion on, which is, you know, this kind of innate knowing you mentioned that humans seem to have of, like, you know, a mindful versus a mindless entity. Um, you know, I wonder if you had any opinions or knew of any research looking at how this specifically interacts with invertebrates, because they're so, like, one of the things I think we encounter is that insects and other invertebrates are so alien in some ways compared
Mhm.
to you know, humans and mammals and other vertebrates. Like, it's very easy to have empathy for another mammal because its face kind of does the same thing that our faces do. But when you're confronted with something as
Yeah.
alien as an insect, I think it's very tempting and very easy to lean into this machine metaphor. Um, so yeah, I don't know if you had any thoughts on how this innate knowing of mind, like mindful and mindless sort of entities, how that might interact with our interpretation of insects in general, and you know how that sort of perhaps feeds into this, you know, this sphexishness that we've been
Yeah.
talking about.
It is a widespread tendency to think of insects in this way. They're innate. But at the same time, once you get to know them better, when you know more about the behavior, you see the variability also there. It's not just instinct. It's not always the same. They can change their ways to some extent, but for us, it's minimal. What also is going on right now, I think, is that there's a lot of attention of studies in a wider range of animals. That's really important now. And people are trying to come up with criteria that you might use to decide whether invertebrate, and then insects are not primary choice, more crabs and other um, yeah, what do you call it? The invertebrates. So crabs are big, and octopus, of course, jelly. What you see there is that is definitely within philosophy working on articulating ways in which we can make a decision whether a crab feels something when it is put into boiling water. And there are criteria that people are now thinking up and deciding on. And now is so there's it's really something that depends on how convincing it is for people to come up with acknowledging, well, yeah, it makes sense. While other people just sort of they don't budge at all. It's and if you look at how how livestock is treated, then there's such a long way to go. So it's again, I think it has more to do with educating ourselves than with the animals themselves. It's more about us than about. It's also our behavior towards insects. That's actually what's at stake here. I think more knowledge will definitely help, and I think the world has changed since there are so many nature programs that show the beauty of insects and how they do things and what is going on and how complex everything is. And it's too general for you, I think. It's not
No, go
my
ahead.
no. It's my sympathy lies there. But what I was saying about the people who are now thinking for criteria for finding ways of deciding whether an invertebrate is particularly significant or not. I am not in that area, and basically because I am my own focus is on these intuitions that we have. Why do we judge something as feeling versus feeling? Basically, I just want to get rid of the difference. And my own work, I'm now sort of trying to articulate what it is to be an animal, what an animal experience might be like in the first place, so that you can have much more tangible results about ethical significance of invertebrate organisms, basically. That's a far off goal. That's not my target, because it's so complex and it's such a long-term project that contribution will not lie there. If I can something contribute, then it will be at a sort of more intellectual level. That's what I can say.
Cool. I think we've got time for one more at least. So we have what do you think explains the lack of attention to modern scientific research of wasp cognition in the philosophical literature on animal minds? If there was so much research on wasp cognition, how or why did Dennett and others ignore it?
This is my own main difficulty, because basically it is because the people who are doing psychology, they're interested in people, in humans. And I remember very strong when I was a postdoc and I was in psychology then, and I got this wonderful research plan, and I came to my professor and said, yeah, that's super cool, that's wonderful. But here you want to talk about jellyfish? Cannot do that. So, and for me, it was precisely the jellyfish part which made it tangible, rather than sort of theorizing. What I think is what is influencing our thought is what happens in the Sphex story. We make a division between us and them, and the them can be anything. It can be real machines, but also anything that is not us. So it can we sort of divide the world in a way where it's based on our own intuitions. So this has been my ongoing problem ever since I graduated, and even before a bit. And what I'm now doing is trying just to get rid of this intuition and come to firmer ground on making a decision that shows or gives hard evidence, stronger ideas at least, for making this connection between other animals and human animals. So it is a problem for me too, and an urgent problem. I find it very hard to handle. So what I do is just focus on the animal side, or wider. It is not strict animal. It's wider than that, and just ignore the negligent and just focus and do the research and live with it. It's hard, especially if you really want to make a wider splash. What I do think is that basal cognition stuff was a way of young people, young research people who are not into psychology, so to say, they became very enthusiastic often enough about how this could show how their jellyfish, their ctenophore, their slime mold could be relevant in a psychological context. And if this grows, then it might sort of become bigger and become part of a bigger research domain, and that might help. So that's the positive side. On the negative side, actually all the animals and such were just part of standard psychology before the 1940s. And then it was normal to hear about rats, but also about vertebrates and about animal behavior at much more so than it is nowadays. So the division has grown since. So there is a sort of going to and fro. It is really a problem.
I hope, well, personally, I feel, and I hope we are making more of the positive strides than the negative. I've certainly read some pretty, what I find to be very horrifying research, like psychology research that was done on sort of chimps and other apes in the sort of 50s and 60s, which I've just seems completely unfathomable to me as a researcher in 2024. But yeah, I think unfortunately we will have to leave things there. Fred, thank you so much for this talk.
Thanks
Greatly
for having
appreciate
me.
it.
It's nice to rethink the Sphex again, and to really sort of see how it is as actual, as relevant, I think, as it was in 2014. So, thanks.
Fantastic. I think I'm not sure if we actually finalized our next webinar. I suspect it will be in October rather than September. I can't quite remember, but do check our website and our, let's say, Twitter feed. I don't want to do the thing. Check our Twitter feed for for more updates on the next webinar. Thanks again to Fred, and I will see
Goodbye.
you all next time.
Mm.